Okay, so now we're going to go to some more complicated examples, and examples where you'll see the power of model spec.
All right, thanks, Trevor. Okay, so we've seen how to have design matrices with just a list of column names. Another common modeling tool is an interaction. So the way we specify interactions with model spec is just instead of just having the column name, we put this is a two-tuple of the two column names. So this tells model spec, make me an interaction of the variable lstat and age. Once it knows how to create the variable lstat and the variable age, it can make the interaction between lstat and age. Okay, so let's just fit this model. And here we have a coefficient. It's just another effect in the regression model.
And in this case, because both lstat and age are quantitative variables, it just multiplies those two variables together, entry-wise.
Yes, we'll see in a moment, there are regression problems where not all variables are quantitative. In the Boston housing data, actually, all of them are, but we'll see many are categorical, and then the interaction would look different. But
yeah.
Okay. So another example, another modeling tool that people might use is to, rather than fit just a linear effect for a variable, might put a polynomial effect. So there's a function poly that allows us to specify a polynomial effect in some feature. Here we'll put a quadratic effect for lstat and a linear effect for age. Again, the model is specified the same way. It's a list of terms. It's just that this term here, poly, has actually two columns corresponding to it. Let's fit the model and summarize, and we can see that the two columns, each one gets a separate coefficient estimate and indicated by this is the first column corresponding and the second column.
Because of course a 2-degree polynomial has got a quadratic term and a linear term.
That's right, yeah. And if we wanted to, actually, we could consider an interaction between the polynomial and age, but we'll leave that for another day. Okay, so now this example here, we've gone from just a linear term for lstat to a quadratic. We might be interested in deciding whether there was really a significant improvement in fit going from linear to quadratic. We can actually see here that the p-value is small, but there's another method that's commonly used, that is the ANOVA method, to compare two different fitted models. So this ANOVA LM function from the stats models, what it will do is carry out an F-test comparing two nested models, and we can use that to decide whether one model is significantly better than the other. This F statistic here, 177.
That's huge.
That's huge, and it's also should be about 13.3 squared, right? That T statistic should correspond to that. Though maybe not exactly. I shouldn't. Always says that. Actually, no, it should in this case.
It should be.
Yes. Okay. Let's see. So part of the section that we skipped looked at residuals of our earlier regression model and noted a trend in the residuals plotted as a function of fitted value. In this plot, actually, we can see that that trend has been removed, but we didn't see the first plot, so let's not dwell too much on it. The last example of model spec we'll use is qualitative predictors or categorical variables. So in another data set in the ISLP package, the car seats data tries to predict the sales of car seats as a function of different features. So different features like the competitor's price. So this may be a chain like Walmart, and maybe we'll compare its competitor's price like Target. Maybe this is income of the typical income in the neighborhood of that particular store, etc. One of these variables is shelf location. This is sort of where the car seat is placed in the shelf. I think low, medium, high are the levels, and so that's we could encode low, medium, high as 0, 1, and 2, but those are kind of arbitrary. So this is really a categorical variable, right? And if we look at the column shelf loc in the data frame, we'll see. Whoops, that's not right. We'll see that it's been recognized as a category by pandas, And so model spec will then, if we use shelvloc as a predictor, it will treat it as categorical. So here we fit a rather complicated model. We first found all the features besides the response sales, and we'll add all those features to the model. And we added a few interactions just for the fun of it. What we're going to see is for the variable shelf location, which is categorical, it will have created more than one column. So here, I guess rather than low, medium, high is good, medium, and poor, I suppose. I don't actually know the levels, but
so it's done. What it's done is it's made dummy variables for these three categories, and you always need to leave one of them out because they aliased with the intercept.
That's right.
And so it's done it all automatically for you. So this is another instance of things you would normally have to do yourself to set up the model matrix. This MS model spec has just done it all for you, made it much easier.
Yes, and there, of course, there are various ways you can add these two columns. So experts, you can, if experts in specifying these can do it their own way if you like, but we're definitely not going to dwell on that. Okay, so that brings us to the end of the lab on regression, and next lab is we'll see you next week for classification.